Okay guys, so now let's move to question 2.2. Let's just get started. So the question, we're actually given a mini statement there for question 2.2, and it reads as follows. So a 200 kg rock lies on the surface of a planet. The acceleration due to gravity on the surface of the planet is 6 meters per square second. Question 2.2.1 says, state Newton's law of universal gravitation in weights. And this question is allocated 2 marks. I think because since that question it's one of those obvious questions, I'll just simultaneously solve these two questions. So it will be an answer for question 2.2.1, and I think some calculations will be needed for question 2.2.2, which says calculate the mass of the planet if its radius is 700 kilometers. So guys, I think, with these kind of questions, you need to make sure that you quickly solve these questions and you move to the next questions, because they are really not that much difficult. And with this one, it feels like it's one of those grade 11 exam papers where you are given 3 marks. So it's more like they are difficult questions in the way, so they're just getting you warmed up with these easy questions. So that's why I'm saying I'll just quickly state Newton's law of universal gravitation in words and quickly solve this question, because it's not that much complicated. I will just show you the formula, and then from there you will realize that it's not even that much difficult. So I think, let me just before I write it down, I'll just indicate to you that Newton's law of universal gravitation in weights states as follows. So okay guys, so in this way we are done with question 2.2.1, which was allocated 2 marks. So by just stating Newton's what is it? It's Newton's law of universal gravitation in weights. That's how you score your 2 marks. So just in case if my handwriting it's, I'm not sure if I should say a bit horrible, or if it's just horrible, I'll just read it so that in case if you can't see properly, you can just listen and try to replay the video so that you're able to write it down as I read it out. So each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So I think if I have to go deep into explaining exactly what's going on there, I might need to then I might as well just do a special lesson. So guys, that was it with 2.2.1. I hope you got the definition and you're able to write it down. So without any waste of time, I think we should now move to question 2.2.2. Let's see. So as I've read before, the question says calculate the mass of the planet if its radius is 700 kilometers. So for this type of questions, guys, as I've indicated, it's one of those easiest questions. You've got 2 formulas that you can use for this type of questions. I'll just write down the first formula. So we are now on 2.2.2. So the first formula is F, it's equals to G m1 times m2 over 2, or G, which is the gravity, is equals to G multiplied by m over r squared. Remember, this is r squared. Sorry about that. So I'm sure you are able to see these formulas on the formula sheet. Let me check if I've copied them correctly. F is equals to G m1 m2 r squared, G is equals to G m over r squared. So in this case, guys, let's check. As you can see, the first formula might need some additional information as compared to the second formula. Instead of having to test if this is the relevant formula, let's check on this formula. So what exactly are we calculating? So we single what the question wants us to calculate, which is the mass of the planet if its radius is 700 kilometers. And most importantly, guys, you should remember that this is a constant, so it doesn't change, and luckily it's always given to us. And if you remember, guys, I've read a statement before which indicated to us that the gravity on the surface of the planet is 6 meters per square seconds. So that means we have the gravity. And I've just read on the question that the radius is 700 kilometers. So it seems like we've got all the information that we need. So it's just a matter of us plugging the information on the formula and then calculate for the mass. So let's now proceed. You've got, obviously, we're proceeding with that formula. So this formula, it may be relevant, but it will be a long dry in this case. So you might find that you will first need to calculate maybe, for example, the force, and then make use of mass 1, and then calculate mass 2 using that as your R and obviously the given as your G. So instead of having to go the long route, we'll just use that second formula. So we've got 6, which is equals to 6.67 by 10 to the, okay, I'll show you where you get that value. Into, we are calculating for m, remember, and then now the radius is 700 kilometers. So by 10 to the power 3, I'm converting it to meters. Remember the squared. So obviously, guys, mathematically, you know that you just multiply by 6, then you divide by this. The answer that you get is your m, which is what you're calculating for. So I'll just bring a calculator so that we calculate the mass. So we've got, okay, so it's 6 times 700 by 10 to the power 3. Remember, I had to convert it to meters. So in physics, we don't measure distance in kilometers. You need to convert it to meters. So that's the SI unit for distance in physics. We measure the distance in meters. Remember the squared. Always remember that squared, because you can easily forget that squared. So it's equals to that number. Then you divide the answer by 6.67 by 10 to the power negative 11, which is equals to 4.41 by 10 to the power 22. So we've got our mass as 4.41 because we round it to 2 decimal places by 10 to the power 22 kilograms. So this is the mass of the planet. So now we'll just quickly just mark the question, and remember this question is allocated 4 marks. So we can give you 1 mark for writing the correct formula, and the second mark, obviously, you'll get it for correct substitution. So we'll give you a mark for correct substitution, a mark for correct substitution. We don't give you a mark for that one because you just copied it from the formula. It's always given to you. And obviously your last mark comes from the final answer. So that's basically how you solve for question 2.2.2. So that's how easy it is. In case if there's some additional questions that you have, you can just post on the comment section and I'll quickly attend to those questions. So that was the end of this question 2. So I think we should now move to a new question. So you can still suggest question papers that you'd like us to solve. And in that way, at least I'll be providing a relevant content for you guys. Thanks for watching.